Memory address map is considered as the reference of the hardware and the software mapping, which refers to a particular location in the memory. It is basically used for mapping of memory for hardware as well as software in terms of computing. Now, how does memory address mapping takes place? Now, first of all, let us understand what do you mean by address and why it is very important when it comes to memory also. We say that memory is required to store the data. Now, there will be n number of data that is getting stored in the memory, but within fraction of second, how that data gets retrieved by the CPU. Now, this is because each and every memory has a particular address that is being associated with it. So when you are typing an instruction, for example, in Google, artificial intelligence. So Google will go and see the keywords artificial intelligence. But before landing into the keywords, it will check the different indexes which are attached with the keyword named as artificial intelligence. Artificial intelligence is considered as an example, what we were stating. Now, memory address map is a pictorial representation assigned address for each chip into the system. To demonstrate an example, assume that a computer needs 512 bytes of RAM and 512 bytes of ROM. The RAM has 128 byte and it needs 7 address lines, whereas ROM has 512 bytes and it requires 9 address lines. Now look at this example. Here in the component front we have RAM 1, RAM 2, RAM 3, RAM 4 and then ROM. And in the hexadecimal address, we are having the address with starting with the 8-bit code. It goes from 10 to 9. For example, RAM 1, it has 4 zeros, then 2 zeros and 7F. When it comes to the address line, only 10, 9 and 8 are indicated as zeros, the rest are considered as null. When it comes to RAM 2, hexadecimal address is 0080, then 00FF. 10 is considered to be 0, 9, 0 and 8, 1. And again, the rest of the components are considered to be 0. When it comes to RAM 3, it is 0100, 017F. That is 010 and rest of the components are considered to be 0. When it comes to RAM 4, it is 0180, 01FF, that is 011, and then the rest is 0. When it comes to ROM, it is 0200, 03FF, and the component that is used is 10, which blinks as 1, and rest are considered to be blank. Now, what we have seen right now, the hexadecimal address assigns a range of hexadecimal equivalent address to each chip. So hexadecimal address is assigning equivalent hexadecimal equivalent address for each chip. Line 9 and 8 represent 4 distinct binary combination. Here, why binary combination? Because we are expecting which RAM should we choose, because there is a possibility that some RAMs would be performing some other tasks. So we need to classify which RAM is free for the operation that we need to perform. When line 10 is 0, CPU selects a RAM, and when line is 1, it selects a ROM. So a simple concept, when it is 0, CPU is selecting RAM. When it is 1, it is selecting ROM. So it eases the work of the CPU also. So now when you see this diagram, here how memory is being connected to the CPU. Now we are aware that CPU is connected with address bus, data bus, read and write signal, which are called as RD and WR. RD stands for read, WR stands for write. It is connected to the CPU. Then we have different RAM 1, RAM 2, RAM 3, RAM 4, and then the ROM. Now, the signal CS1, that is signal 1, signal 2, AD stands for address, and RD and WR are read and write, are being assigned to the different data bus which are being connected to the data. And we have the address bus. And all of these operations are being controlled with the help of CPU, which is directly linked with the system bus. And then we have a decoder which is connected with all the RAMs and ROMs, and it is directly connected to the CPU. Now, when the RAM operation takes place, so you see, so the decoder gets the signal, it decodes the signal, and it gives the signal to the CPU. So, accordingly, what we have seen previously, according to zeros and ones, CPU understands if the signal is between zeros and ones, it should fluctuate between RAM or ROM. And all of these RAMs and ROMs are directly connected to the data bus. And via data bus, it is connected to the CPU and the address bus in a sharing mode.